All right, so we are going to talk about 4.5, which is focused on analyzing group data. When individual data measurements are not readily available and we are given a frequency distribution, this is called group data. They can't give us the raw data, but instead give us a frequency distribution. So they don't give you the exact scores and what they were. They just give you, okay, between 60 and 67, 5 of those came up, and 68 to whatever, 9 of those came up, okay? To find the mean, variance, or standard deviation of group data, we should use the following formulas. Note these outcomes will be approximated. So looking at the mean of group, these are our formulas, but before we do that, population mean is that mu, big N is population size, that squared equals population variance, x bar is sample mean, little n is sample size, S squared is sample variance, and that's the summation. That E looking thing is sum. F of I is the frequency of each class, so how many times it happens in each class, and then M of I is the midpoint of each class. So to find the mean, you take the F of I, the frequency of each class, multiplied by the midpoint of each class, sum it, and then divide it by the big N or the little n, depending on if it's a population or a sample. If it's a population, it's a population size. If it's sample, it's a sample size. Okay, and then the variance of group data. Okay, this one's a little more difficult, so you're going to take that M of I, or the midpoint of each class, minus the mu, which is the mean that you just calculated over here, squared, multiplied by the F of I, which is the frequency of each class, divided by the big N, and if it's a sample, it's going to be little n minus 1. Okay? Alright, so let's go ahead and try this out. It's going to be a lot of steps, so follow along. A frequency response time for 911 calls from the EMT is shown below. Calculate the population mean. Round your answer to 2 decimal places if necessary. So, step 1, if we go back up here and look how to find the mean, you're going to take the frequency of each class multiplied by the M of I, or the midpoint of each class. So let's go ahead and find the midpoint of each class. So I'm going to do equals 6 plus 6.9, and then we're going to divide that by 2, right? Okay, parentheses are important. Divided by 2. Okay, and I'm going to do that same thing. So 7 plus 7.9, parentheses, divided by 2. And so you kind of see that it's 8.45. This is going to be 9.45. This is going to be 10.45. This is going to be 11.45 and 12.45. Okay, so these are your midpoints. These are called midpoints. Okay. After you get the midpoints, now I'm going to take the midpoints multiplied by the frequency. Okay, that's what that said to do up there. So equals the frequency multiplied by the midpoints. And then you're going to scroll it on down. And to find the mean, okay, then you have that big E. So if you come back up here, you have that big E. So that was the frequency times that big MI. And then we need to divide that by that N. But we have to first find the sum of all. So equals sum of all these midpoints and frequencies divided by how many they just did. So I'm going to take this and divide it by how many they did, which we need to find first. So let's find how many frequencies we actually had. Right? Okay, so 217. So to find your mean, which I'm going to go over here and put, I'm going to take that midpoint frequency added together, divided by how many data sets they had. And so I get 9.54, but we have to round it. So round to 2 decimal places. So 2, 9.55 would be the mean, 9.55 minutes. All right, let's go to the next one and let's step through it. So now we have to do the same thing, but we're going to find the population variance. Round your answer to 2 decimal places. So I just took this information, that midpoint section, put it here. That midpoint times frequency, put it here, okay? So again, I'm going to go ahead and do equals sum all of these together here. And then this equals the sum of all of those together there. And then my mu is this divided by the sum of all of them, so 9.55. All right, now calculate the population variance. So if I'm looking up here, my first step for that is the M of I, or the midpoint, minus my mean. Okay, so I'm going to do midpoint minus mean. Midpoint minus mean. Okay, so if I do midpoint minus that mean, it's right here. And I'm going to put that reference so it stays there, that mean, and that midpoint changes. And I drag it down. Okay, and that is what you should get for the midpoint minus the mean. The next step was square that. So midpoint minus the mean, and you're squaring it. Okay, so I'll put this in parentheses, that, and squared. And I'm going to go ahead and drag that again. Okay, after you have the midpoint minus the mean squared, your next step, if you come back up here, midpoint minus mean squared times the frequency it happens. So we're going to take midpoint minus your mean squared multiplied by the frequency. Okay, so this is the midpoint minus the mean multiplied by that frequency, which was 21 on this case. Okay, and then you're going to still drag it. Okay, coming back up here, we're going to now divide by, we're going to sum it, right? We're going to go ahead and sum this. Well, sum of all these, because that E, or that symbol that looks like an E kind of, okay, that is the sum of all these. And then this is a population mean, right? So population, so we're looking at population, so we're just using N again. So the variance is going to be this divided by N, which was your 217. And your standard deviation is really just the square root equals the square root of that previous number. Okay, it doesn't ask for standard deviation, but we might as well give it because we know the square root of the variance is the standard deviation. So 2.96 whatever minutes and 1.7213 minutes. Okay. All right, now calculate the sample variance of the following frequency distribution of a heart rate for the sample American. So this is a sample one, so we have to be careful with this and make sure we're doing n minus 1 at the end, okay? Make sure you're doing that n minus 1 because it's a little different. Okay. All right, so let's go ahead and do this. So the upper limit, let's just fill these in, 51, 59, 67, 75, and 83. Okay. Oh, that's the lower, sorry. Oh, I have these flipped. Let's do lower first. Lower, this is your upper. Okay, upper is 58, 66, 74, 82, and 90. Okay, so your midpoint, I'm going to do this. And I'm going to put this plus this, right? Divided by 2. Drag it down, just make my life easier. Okay, now midpoint times frequency, so midpoint multiplied by that frequency. I'm gonna go ahead and drag that all the way down. I need to have the sum of all of these in order to find the mean also, so the sum. Okay, and again, your mu is going to change because when you look at your mean, you don't do the minus 1, but the variance, you do that n minus 1. So keep the n the same for the mu, but the variance changes because it's a sample. Okay, and so we're going to sum all of these. That's my next step, midpoint times frequency, sum. And then we're going to take that divided by your frequency and to get your mean. Okay, that is your mean. I'm going to go ahead and round this just so to 2 place values make our life a little bit easier. Okay. Now midpoint minus sample mean. So I'm going to do equals midpoint. Right, this is to find the variance. So we found the mean. Now to find the variance, you do midpoint minus that sample mean. We're going to put the dollar signs around it. Oops. Okay, and we're going to drag it, make it faster. Okay, and then we're going to square it. So this times this. If you look back up at that formula, we're squaring it. We drag it down. Okay, and then after we square it, we times it by the frequency. So we're going to take midpoints minus that, minus the sample mean squared, and then that's times the frequency. Okay, and we drag it on down. Okay. All right, so then we sum it all up. The top part of that fraction, we sum on up. Maybe pull it on down, sum it. Okay, and since this is a sample, we have to take n minus 1. So you can either do this divided by n minus 1, which is 43 minus 1, or you can just know that's 42. And then this, you just square root it to get the standard deviation. Okay. All right. So that is your, that problem. Okay. And we label it, so your label is, we're talking about heart rates. So rate, right? Still BPM. Okay. You can label it BPM, beats per minute, beats per minute. Okay, moving on to the next one. A client of a commercial rose grower has been keeping records on the shelf life of a rose. The client sent the frequency distribution to the grower, calculate the mean and variance of the shelf life given the following frequency distribution. So we're doing the same thing. So I'll first put these in here, 1, 7, 13, 19, 25, 31, and over here we're going to have 6, 12, 18, 24, 30, and 36. Okay, so midpoint, we're going to do upper plus the lower. Oh, make sure we put parentheses. Upper plus the lower divided by 2. And let's go ahead and just scroll that down, make it fast. Let's make the sum of the frequencies to figure out how many people we actually gathered data from. Okay, midpoint times frequency, so equals the midpoint times your frequency. This is to find the mean. You did the midpoint times the frequency. And then we sum it. Okay, sum. And mu will be that divided by your n, big N or small n. Okay, and that is 17.5 for our mu, or our mean. Okay. All right, so now we're going to do the midpoint minus the sample mean. This is to find the variance. So we found the mean, now we're going to find the variance. So equals the midpoint minus the sample mean, right? And we're going to $ this up to make sure it's referenced, doesn't change, and we drag it. And our next step is to square this. So we square it, we drag it all the way down. And then lastly, we times it by that frequency. So this multiplied by frequency, it actually happens. So 2. And we go ahead and drag that. And then the top of that fraction, it says sum. So we have to sum all those together. We have to make sure. Okay. And now let's read it. A client of commercial rose grower has been keeping records on the shelf life. The client sent the frequency to the grower. So this is all the shelf life, right? So this is all that client's shelf life. So this is the population of that shelf life. So I'm going to do equal this divided by that 24. Standard deviation, we square root it. Okay. And we end up with that, and this would be